Welcome back. We just reviewed how transformations work, horizontal shift, scale, vertical shift and scales. Now we are going to see how they work in trigonometric functions. And so that general transformation model that we saw before, f of x or f of bx minus c plus d with a out in front, I forgot about a, we adapt that just using sine and cosine. Okay. Now, A, B, C, and D, they function very similar to what we know about general transformations, with the exception of one. Okay, so first of all, A, this is still our vertical scaling. Okay, and so with this, we just take the y's and we multiply them by A. Okay, and then we also, from this value, we get amplitude of at least sine and cosine by taking the opposite value of A. Okay. Now I'm going to leave B for a minute because that's the one that's a little odd. But, or sorry, B is actually fine. C is the one that's odd. B, what this tells us graphically is the number of cycles made in 2 pi. Okay, so if it's 3, it tells us it makes 3 complete revolutions in 2 pi. So then, consequently, if we want to find the period, mathematically, all we have to do is take 2 pi divided by b to get a single period. Okay, so that's kind of nice. C is the one that's odd. Technically, there isn't a good name for this, but when we look at phase shift, okay, this phase shift is our horizontal shift. Okay, and how we find this algebraically is we take C divided by B. Okay, and note that if we have a bx plus something, we need a minus. We need to treat that as an opposite. Okay, and then D is still our center line shift or vertical shift. Okay, and also called center line shift. Okay, so D moves this thing up and down vertically. Okay, now in terms of transformations, right? Generally, what I always recommend is to do horizontals first, which would mean to do B and C first, and within those, typically you shift and then scale. So typically it's 1 and then 2, and then after you do horizontals, then you do the verticals. So scale in that case, and then shift vertically. Now, in practice, what we do actually, it's really weird, but we do this first. So we incorporate the cycles first, or that period aspect, and then we shift. Okay, typically. Okay, so we'll see, but otherwise, we just need to make sure that what we have is ultimately the same as what Desmos might give us, for instance. Okay, so now keep in mind, transformations, it is an alternative. We still have those 5 key points. So unless I explicitly say in this exercise you need to do it using transformations, you can use the 5 key point method. Okay, but this transformation, it's a nice alternative. Okay, so these functions, we actually haven't seen these before, but we are going to do these via transformations. Okay, and we need to identify period, amplitude, phase shift, vertical shift, all before we end the exercise. Okay, and the key points, you'll see how we incorporate those as we go along. Okay, so first thing, what I want to imagine is that this is normally a sine function, right? So we might have sine x normally, okay? And then something happens to it, okay? Then we're going to need to do some horizontal transformation. So we have sine of something, and there's actually 2 of them, right? There's this pi over 6 and this pi over 2. Those are both horizontal, and the 1 and the 2, negative 2, those are vertical scaling or vertical transformations. So we need to work out those. But So we have sine of something, and then we have sine of another something. So both of these are going to be horizontals. We got to figure out which one they are, or which one goes where. And then after this, we're going to have vertical something. And so we're going to have sine of something, and then another vertical something, sine of something. Okay? So first, in going from sine x to this first stage, I need to think, what would I do normally first, right? We would generally shift first, and then we would scale, but with trig, it's actually easier. Okay, so you can do it in that order. It's actually easier if you scale first, okay? So we're going to scale by factor, and then remember, trig, it's always opposite of what we imagine. So we scale by 6 over pi. Okay, normally you could also say it's dividing by 1 over 6. Okay, a little odd to write. We'll see how it works out mathematically. Okay, so we do that first, and then mathematically or algebraically, we would represent the transformation as pi over 6 x. Okay, next, the only other horizontal transformation we have left is the horizontal shift. Okay, and this would be by whatever our phase shift is. So it might be wise to take a moment and just calculate phase shift. Okay, phase shift, remember, it's calculated by c over b. So I would take pi over 2, and it is negative in front, so I don't need to include a negative, and divide that by pi over 6. So then multiply by the reciprocal, right? I just get 3. Okay, so phase shift by, or horizontal shift by 3 units, okay? And then algebraically, we would have pi over 6x minus pi over 2. Now, another equivalent way to express this would be pi over 6 parentheses x minus 3, and you'd have like double parentheses in there, and you distribute it, and then you can very clearly see the phase shift, okay? Either way works, okay? Now, horizontals are really weird, I admit it. Verticals are much more straightforward. Verticals, we always do the scaling first. So we scale by factor minus 2. So that puts a minus 2 out in front, and I'd have pi over 6x minus pi over 2, and then we would shift last by 1. Okay, so we have minus 2 pi over 6x minus pi over 2 plus 1. Okay, whew, we got a lot to do. So let's see how it plays out. Okay, so we need to set up my graph, and I can tell you if I need to scale by a factor of pi over 6 horizontally, right? That's going to go a ways out. So normal period. So just for our sake, we can calculate period as well. Period is normally calculated as 2 pi, and then, but I have to divide by b, so pi over 6. So this is 12. So I need 12 units to make one repetition of this thing. And then, right, I still need to shift it horizontally by 3. So I need to go out to 15, perhaps. And then, okay, so then from there, right, vertically, it's actually pretty easy. So let's see, vertically, I'm going to scale by -2 and then 1. So maybe allow for, 3 in every direction. So I'm not too concerned horizontally or vertically. Horizontally, maybe it's wise to increment by 3s. And again, if you still wanted to calculate increments, you can take the period and divide by 4. So this is 12 over 4, so 3. Okay, it actually works out pretty nice. So maybe let's do this: 3, 6, 9, 12, 15. Okay, and then maybe just do normal units. So this would be 3 and minus 3 here. Okay, so let's go ahead and sketch this thing out. Okay, so normal sine is going to be really weird because normal sine doesn't quite fit this scale, right? It would start at 0, and then, you know, if I'm saying that 3 is about pi units, right, and then 6 is about 2 pi units, so this is going to be off slightly. This is why we have a sketch. But again, sine would make one full cycle in 2 pi units. So I'd have something like this, and then about halfway in between, I'd have this going on, okay? It has that general up and down motion, okay? So this is just sine x, okay? Now I'm going to follow what the transformations say to do. So I'm going to scale by a factor of pi over 6, or 6 over pi, rather. So take all the x values, keep the y coordinates the same, multiply by 6 over x, or 6 over pi. So that's going to bring, let's see, I'll do these in green. So 0 is going to stay at 0. Okay. So thinking of this as, you know, pi comma 0, right? This would move out to 6. Okay, so that would move to there. 6 would move to 12. Okay. And then this would be pi over 2, multiply that times 6, I get 3. So right there. And then this one is at 4.5, that would move to 9. So already I have something that looks like this. Okay, so this is the sine of pi over 6x. Okay, next I need to shift, right? I need to shift 3 units. So 3 units to the right, 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 3 units to the right. Oops, undo. Right like that. Okay, and then this would be the sine of pi over 6x minus pi over 2. Okay, that was what I said I would do second. So I've done this one. Maybe I'll just keep these color-coded. Okay, so I start with that and then I do these transformations. Next one, oh, that was in blue. Okay, next one, I guess I'm going to do in black. Okay, so 3, I'm going to scale by a factor of -2 vertically. So that takes all the y values and multiplies them by -2. So right there, that one stays the same, that one stays the same, this one multiplied by -2, and there we go. So we have something like this. So this is -2 sine pi over 6x minus pi over 2. Okay, and the last one that I'm going to do in purple here is to shift by 1 unit. So I have all these points. Shift them up 1. Yeah, this is going to look a little messy. That's fine. Shift them up 1, shift them up 1, shift them up 1. So I have something like that. Okay. So this one, I didn't go forward and like do the coordinates for each one because it would be kind of messy, but you could do that too if it helps you, okay? And just follow these through in order. In all, right, we're using transformations as we've seen them in the past, at least vertically. Horizontally, the story changes a little bit, right, because we practically, we always do the horizontal scale first before the horizontal shift when we're working with trig functions, just to make it easier to work with, right? So like the first graph that we started off with, the blue one, was just sine x, and then that was a little cumbersome to work with, so we do the scale to get it right kind of lengthwise first, and then shift it from there. And again, the the shifting part isn't by C, it is by the phase shift. So that's the other thing you need to bear in mind. But we'll get some more practice with these.